The main mission of the Maryland Robotics Center is to advance robotic systems, the underlying component technologies and applications of robotic systems through research and education that is interdisciplinary in nature and based on a systems approach.
We have a great variety and diversity of talents and specialties that we have here. Many labs from different aspects of robotics.
The Maryland Robotics Center consists of over 40 faculty, a number of unique facilities including the Unmanned Aerial Systems Test Site, the Fearless Flight Facility, and the Neutral Buoyancy Research Facility.
The Fearless Flight Facility is an outdoor netted facility that we have close to campus. We are located within the flight restricted zone here in DC, so we do a lot of test flights out there.
Today we are here at the Fearless Flight Facility, where we have multiple quad rotors which are taking off. They're using synthetic flight data to complete this map and search mission. As they explore the environment, they use the idea of mutual information to guide their search.
The eReeb Drone Lab is a brand new shared lab that allows us to study aerial robotics using motion capture cameras.
My work in drone racing involves a lot of integration. It starts with the hardware in terms of building a drone and getting it to fly, integration of sensors and getting that connected to the drone itself, and then a lot of programming. We try to figure out what the camera is seeing and try to integrate that with the drone itself.
We try to think of robots, whether they are one or several, as a system. And we try to have this wholesome approach to the design of the robots, to the evaluation, and so on and so forth. And that's kind of unique. All right? So one example is this. I'm trying to design robot arms. Can you do the design before you go create a single screw? That's how we do airplanes today, but we don't do this for robots. So there's a little bit of a strange thing here, right?
In the Bio-Inspired Advanced Manufacturing Lab, or the BAM Lab, we try to use micro and nanoscale 3D printing technologies to solve biomedical challenges. And so in the context of robotics, we're trying to create an entirely new generation of soft prosthetics that are built using 3D printing. The way that we build our soft robotic systems is that we use a special type of 3D printing. And what makes this type of 3D printing special is that it's just like a color printer, but instead of printing just one page, we're printing multiple pages, one on top of another. And what makes it great for soft robotics is that we can print different types of materials, like soft, flexible materials and hard plastic materials that are fully integrated, so that after the printing process, in a single print run, we have something like this.
The Neutral Buoyancy Research Facility is the largest underwater research facility on a university campus and the only one equipped with underwater motion capture. This is where we study autonomous underwater robots and space systems using the underwater domain to simulate microgravity.
What we have here is a tank that's 50 feet across and 25 feet deep, and we use it to simulate space. There are only 6 tanks like this in the world. This is the only neutral buoyancy facility in the world on a university campus, and it's one of only 2 active facilities in the United States. We're very pleased to have this unique facility. We put our robots in the water. We actually put people in the water, either directly as if they were inside a habitat or wearing spacesuits. We're actually developing robotic systems that operate in many different environments to try to ensure that we can have the technology available as we advance outwards into space, that we'll have robotic systems ready to go along with the humans. One of the unique things about this laboratory is everything you see here is designed and built here almost entirely by the students. So if you look at a robot arm like this, that was originally developed to fly in the space shuttle, it was developed by students, and we still operate it using graduate students and undergraduates. We try to involve students across the spectrum, from freshmen all the way through seniors, graduate students, and get them all involved in the engineering development process.
I'm only a small part of this, so I'm a faculty advisor, which means that I sit in my chair and really think up cool ideas, and then the students are the ones who are actually executing. So they're the ones who actually know what's going on, how to fix things when I break them, and actually are the ones who are executing.
Here in the lab, we have 4 faculty from computer science and engineering who work here. We have postdoctoral research associates that they work here. These are people that already have gotten their doctorates. We have graduate students, we have undergraduate students, we even have high school students. And they work in little teams, doing experiments, doing theory. The future of the center is very bright.
Come to the University of Maryland. It's a great university. you ought to go to grad school here, you ought to go to undergrad here.